All right, so part two, we're going to talk about the Java section, again, since we know about 70-80% of our tests are going to be in Java. This unit, we're going to talk about the anatomy of a class. When we talk about classes, do you remember when we went over this, this was in module 1, I had all the different color houses, right? We said we had a house class and it created house objects, and then we talked about using object.method. We did this with strings, like when we did the word, when I printed out the parts of the word, the quadrilateral, it was word.substring, object.method. It was the object, and then dot, and then I call the method or the action. We did with rectangles, right? I had a box, and I did a get x, get y, or translate. So we had the object.method, and we talked about using objects. So you know how to use string objects. You know how to call the methods like substring or length or index of, but where's the rules for those objects defined? That's in the class itself, the blueprint to make these objects with. So that's what we're going to talk about today. And we're going to talk about the anatomy of class. We're going to talk about constructors, instance variables, methods, and scope. I'll break that down a lot more on the next few slides. To get some backup information in this, in the study.com. Now, there's two chapters in the study.com that you should look at. One of them is the FTCE Computer Science K12 Study Guide, which is great. But there's also a study.com chapter, the Java Programming Study Guide, and that has a lot more CS Awesome-like information as well. So in addition to CS Awesome, I skipped some units. I skipped some sections, but Unit 5 of the CS Awesome course is all about this class, designing classes and the anatomy of a class. That's Unit 5 in CS Awesome. But check out 6 in the Java Programming Study Guide, and then it's kind of scattered throughout chapters 6 and 7 of the FTCE Computer Guide. So that's what we have in our resources that are available for us. All right. So what is a class? So the idea of a class, and object-oriented programming in general, is the idea of this black box, right? It just does its thing. If I put, and even my students do this, if I put like a radio in front of my students, you know, remember there's a thing called radio, you hear it in music. But I said, could you make this play music? And, you know, kudos to them, they can. They know how to turn it on, and they can eventually tune it to a station, and there'll be a commercial or something instead of music. But they make sound come out. And they all figure out, yes, you turn it on, you tune it, you pull the antenna up, whatever, you turn the volume up and get music. Great. How does it work? No clue. But they don't need to know that, right? Because it's a black box. It hides its workings, right? How does a car work? You don't have to be a car person to know how to put it in gear, hit the gas, and go. You don't need to know how a carburetor works or how a transmission or any other part that I can't name right now works in order to drive a car, right? You just have to know how to use it. And that's what the idea of class and object-oriented programming in Java is. This idea of encapsulation. It takes everything about a single unit that is tightly defined and puts all of that together. We're not going to have a class called stuff. We're not going to have a class called kitchen sink, which is everything. We're going to have a class called house or rectangle, right? Specific items that have actions that we can perform. That's encapsulation. Abstraction is the idea of hiding the details. I can call this method on my house or Jack's house or Bill's house or Sarah's house, and they all do the same thing even though they're on different objects, because all of those objects were built using the same blueprint, the same class. So this idea of abstraction, all we had to know is I turn the volume up of a radio, the music gets louder. I'm good. How does it work? No idea. There are these things called radio waves that fly through the air, and they somehow land on my antenna and go through. No idea. But it works, and I get music from it. That's the idea of abstraction. So here's some examples here, right? So like I mentioned a car. A driver drives a car, right? But even at the car builder, there's different levels, right? The automotive engineer might design the car and use these control units, but they have no clue how those control units work. They know it's necessary to build a car, so there might be a car parts designer that makes these, and then they even use the little capacitors and whatever, small little minor parts that they just know that that's what they need, and it works to build their car. So there's all different levels of abstraction. With computer software, it's the same idea, right? When you use a computer, you're using a program, maybe using like Google Docs or Excel, but there's a person who wrote that code, and you don't know how the code was written, but you know how to use it. Well, they designed that code, and maybe they're using certain objects that someone else designed, and then this person's using other objects that is maybe low-level systems programmer design. So even people who are writing code don't have access or need to have access to all of the levels of code, all the different levels that are there. They just have to write design blueprints that work for the code that they're writing. So we have abstraction and this idea of encapsulation all over the place. Because you are going to write blueprints to make objects, and you're using blueprints, other blueprints, to use objects so that your objects work. And that's where we have this all these multiple levels of abstraction. We're going to encapsulate our routine software computations to black boxes. The programmer using an object only has to know what it does and what it expects. And then the programmer defining a class, making their own blueprint, has to define the behavior and implement it. Now, for you, for this test, you're not going to have to design any classes. You might have to look at a class design and see, oh, this is what that is, this is what this means, and we're going to get into that. So you don't have to write any classes on the exam. You only have to know how to read classes and explain how they work and understand how they can be used in a larger program. Students taking a computer science class would have to write all these classes themselves and design, and that's what we do here. So keep that in mind. And our assignment's going to be writing a class, but I got you started here on it. But if you can write some of it, then you're going to have a much better understanding of how it works. So let's talk about designing a class. And our first class we're going to look at is a bank account. Everyone's familiar with a bank account, right? You go to a bank, you have an account. What are some of the things that you can do with a bank account, right? So you go to an ATM, you put in your card, your PIN, and then what can you do with a bank account? What are some options you have? Deposit money. Everyone says deposit first, my students do as well, and no one does that. Everyone withdraws money. No one puts money in. Y'all want to act like we're saving, but you know. So deposit would be one. Withdraw would be another. What else?
Check your balance.
Check your balance. Good. Anything else?
Transfer.
Transfer from one account to another account would be good. Also, your account, you gain interest. Now, that's not something you do from an ATM, but that's something that your bank account does, right? So that would be some things. So we're going to stick with these for right now. Transfer is another one we're going to talk about a little bit later. But so what are the behaviors? I can deposit money, withdraw, get balance, and add interest. So those actions are going to change to methods of a bank account class, right? These are going to be the actions. Object.method, right? House.paint, or myhouse.paint. My cereal box dot translate. I'm going to say, Bob's checking account dot deposit, right? Brittany's savings account dot withdraw $500 or whatever it might be. These are my methods, the actions that I'm going to do. So how do we make a bank account? Well, we did this already with the rectangle class a while ago. We looked at, so I say class name, bank account, which I haven't even written it yet, but we want to define how we're using it so we can then write it ourselves. Bank account, college fund equals new bank account, and then I have parameters that I'm going to put in here. That's going to be $1,000. So it's going to make a new bank account with $1,000. How does it work? We don't know yet. We haven't got to that. How would I then make a deposit? Well, again, just like word.substring or myrectangle.translate, right? Or bobshouse.paint, I say collegefund.deposit. I keep repeating that because I want you to get in the habit of it's object.method. Oh, and then any information I need, the parameters in there, right? When I called substring, I had to say, oh, substring, great. Where do you want to start? Where do you want to end? Right, 0, 1. You had to give it parameters. Here, oh, how much do you want to deposit, right? You can't just say, hey, I want to make a deposit. How am I? Oh, I want to deposit $2,000, right? You have to give that information when you do that. I can transfer. Now I didn't have a transfer method, but what is a transfer? Isn't it just withdrawing from one account and adding it to another account? So here, I have an amount, which is $500. I could withdraw an amount from mom's savings and then deposit that amount into dad's checking, right? So that would be where the money is. Now, this is where I have to check with students because they go, wait a minute, the money didn't actually transfer. It just, one says they deposited, one says they withdrew, but there's no money. And it's like, it's not this is the Wild West where you actually had a bank and there was like little drawers and you put the money in the drawers, but that's not how banking works now. It's just, we keep track of what you have, but there's no little drawer with your money in it somewhere, right? And what would happen if everybody tried to withdraw all the money out of their bank accounts right now? everything couldn't happen, right? No banks have that kind of cash on hand. So we talk about how this is just, it does it electronically, and that's how the world works, right? I could print the balance. So these methods are going to actually modify, modify our instance for our objects. We're going to change the balance here. But if I call momsavings.getBalance, that's going to give me some information, right? And I put it in a print line, so it's going to print down what the balance is. Notice it's a method, but there's nothing in the parentheses there, because when I say, hey, can I have the balance? Can I have mom's checking account dot the balance? Give me the balance. You don't have to say, give me the balance 600, right? You don't have to tell them how. You're asking for the balance. You don't have to say any information. All they need to know is what's the object and what that you're trying to get the balance of. So that's our object of the method. Now we haven't written the class. This is just how we plan on using it, and this is all good use of the bank account once we have all this code written. All right. So just real quick, how could we use the methods of the bank account to empty Dad's checking? So what would I use if I wanted to wipe out Dad's checking, because that happens all the time. So it would be what? Dad's checking dot, what method would I use? Withdraw, right? I would use Dad's checking dot withdraw, because those are the methods I have. What would be the parameter? So remember, it's going to be the balance. How do I get the balance? Object dot method, it would be whose balance? Dad's checking dot remember this method, get balance is the method that we're going to use, right? Get balance, we said these are going to be our methods, so get balance. So this would be what I have to do, it would look like this. And I don't think I have that on there on your slide, so I'm going to write it down. Dad's checking dot withdraw, and then how much do you want to withdraw? Well, what's Dad's checking balance? Well, it's $5,000. That's how much I want to withdraw. Dad's checking dot withdraw. So what's it going to do? It's going to go, object dot method. It's going to get the balance of Dad's checking and put it in a parameter for the withdraw method. So Dad's checking dot withdraw, and that's going to withdraw the amount of money that was in the balance for Dad's checking object. Good here? So this is how we would use, so we've talked about, okay, so we have all these different objects. We can call deposit, withdraw, get balance, and add interest. I didn't do that one yet, but those are the different things that we can do. So how are we going to write the class? Well, now let's look at the code, the syntax, right? The rules for writing a class. So to define a method in a class, we are going to say the method is either be public or private. Public means anyone can use it. Private would be something that is only internal. Like, let's say as part of the add interest method, I had to call an abstraction that did some calculations for me. Or maybe I was going to add interest, but it depends on, the interest is going to be based on how long you've had the account. Maybe the interest rate is higher if you're a gold member or whatever it is. So that might be, call some other abstractions. But the return type, which is going to be what value I get back, or void means it doesn't return anything. The name of the method, the list of the parameters, and the method body, or the code, is going to be in curly braces. So it looks like this. So here's what our class is going to look like so far. So we're going to have this class called bank account. This is my blueprint. And it starts off with public class bank account. Now, even our programs that we did, public static void main string args in to start off, that said public class like countdown or public class magic 8 ball. This is public class bank account. And here's my methods. Public, now void means I don't get any information back. When I make a deposit, it just says, oh, you made your deposit, great. Same withdraw. It says, hey, withdraw 500. It goes, great, we withdrew 500. Add interest, and maybe I'm going to send it the interest rate, and it'll say, well, we've added interest to your account. What about get balance? Oh, we're going to give you some information back. So this is the type. What type of value am I going to get back when I ask for my balance?
Dollars.
It's going to dollars and cents, so it's a double here, right? That's what happens when I do my my get balance. So these are my 4 different methods. Now you'll notice I've got curly braces here, but there's no code in them yet. So we don't have any code, we just have our method names. This is how we would define our method names in our class. So we've got deposit, withdraw, add interest, and get balance. All right. In addition to that, we need something to keep track of what? What are we keeping track of with a bank account? The balance, right? So how much money we have in. So we're going to need, in addition to methods, we're going to need something called an instance variable. An instance variable is when I make a class, when I make an object, we instantiate a class, or we make an instance of that class to make an object. I had a house blueprint, and I instantiated it to make Jack's house, or I instantiated it to make Tim's house. Here, I would instantiate bank account to make Dad's checking. So an instance variable is a variable that stores the attribute of the object. Each object has their own balance, right? Remember, each house had its own color. Each house had its own location. Each rectangle had its own X and Y value. Each bank account that I make is going to have their own balance. They don't share a balance, right? So if I deposit into Dad's checking, Mom's savings or Bob's college fund doesn't change, right? And so we talked about that with the houses. So inside the bank account, before I do the methods, I'm going to have an instance variable. Instance variables are always private. We don't want someone, you can't go to an ATM and say, make my balance $5 million. You have to, because it's private, it's locked. What do you have to do? You have to call the deposit method. And it's going to actually make you put money in and then change your balance, right? So you can't just change your balance. You have to call the methods. So this is private. And then what is balance? It's a double, it's a decimal number. And that's my balance. You can have multiple instance variables. Maybe I keep track of the balance. I keep track of your name, your address, your phone number, the number of years you've been a customer here. It could be a lot of information, but for right now, we're just keeping track of the balance. So again, here's just a visualization. College fund would be its own bank account object with a $1,000 balance. Mom savings, a bank account with $8,000, right? So each bank account has its own balance. I could call mom savings.withdraw, it would change this one. I could call college fund.deposit, it would change this one. These are independent objects, even though they were made from the same class. And that's the big idea we're getting across here. All right, so we've determined so far what? We've determined the methods we needed. We have our instance variable balance, and now we have to write the code for the method and also something called constructors. So what is this? We're going to write the code. It's code that you already know. You're going to see all this code. You'll be like, oh, we've done this already. And we have to think about what is the responsibility, the purpose of each method. So first of all, let's talk about the constructor. The constructor is what gets called when you say equals new bank account. And remember I said $1,000? So what am I going to do with that $1,000? I want to take whatever was in that parameter, and that's going to be my balance value. That's what we want to do here. So inside the class, I'm going to have, now notice about a constructor, it looks like a method, but there's no return type. It says public bank account. This one says public bank account. It's public because someone needs to be able to use it to create a bank account. And it's called bank account. It's the same name as the class. So when you say equals new bank account to make a bank account, this is what gets called. If I make a bank account and I put nothing in the parentheses, I'm going to initialize my balance to be 0. Now notice, I don't say double in front here. Why not? The reason I don't say double is because I did it up here already. And you'll see the whole thing when I put it together. I declared it up here. Now I'm just going to set it. If I go to a bank and I say I want to open a bank account, they say, do you have any money to deposit? Say, nope, I just want to open a bank account. So what's your balance? 0. It could be maybe the bank accounts have a promotion, open a bank account, we'll throw in the first $10 and you can say balance equals 10. Something like that. It doesn't have to be 0. However, what if I do put money in or put a value in there? Well, I put a parameter here called init balance for initial balance, and I use that to assign a value to my balance. So if I put $1,000 in there, init balance is 1,000, and it's going to assign it to balance. So now my balance has a starting value. Which one do I use? I could use either one. How does the computer know which one you're using? It's going to say, well, did you put anything in parentheses? Nope. I'm going to use the first one then. Your balance is going to be 0. Did you put a number in that parentheses? Yep. Well, then I'm going to use the second one, and we're going to make your initial balance equal to whatever you put in as initial balance. That's what your balance is going to be to start off with. So here's our bank account so far, and it's kind of getting big, so I have it in 2 columns, but this is one big file. So public class bank account. I've got my instance variable, which is my balance. Remember, this is my blueprint for creating any bank account, right? I've got my constructors. One of them sets my bank account to 0. The other one sets my bank account to my initial balance. And then here's my methods. Deposit, withdraw, add interest, get balance. I still don't have any code in there yet. I haven't got to that. So I've got my blueprint. It has a balance. I have a constructor that initializes my instance variable. And then I have my methods. This is all the parts here. So finally, let's look at what happens here when I call the constructor. So let's say I make a bank account college fund equals new bank account 1,000. What happens when I write that line of code and I've got my blueprint made? Well, what happens is I'm going to create an object of new type of bank account. It's going to call this, so it creates a memory location for this bank account. It calls the second constructor, because I put money in here, and notice I didn't put 0.00, it adds the 0.00 for me. So it's, even though it's an integer, it converts it to a double. Since I have a parameter, it's going to do what? It's going to set that init balance to be 1,000 right here. It's going to set the balance instance field to whatever initial balance is, which is 1,000. And then it's going to return an object reference. It's going to return the memory address of where this object is to my college fund variable. And the college fund variable holds the address of where that object is in memory. And now the college fund is my object variable and my reference variable, and it's going to hold the location of where this bank account is in my computer memory. Now, what's it going to do? I don't have any code yet. Can't do anything. I just put the money in there and it just sits there. But now I'm going to implement some methods, and this really isn't that hard. So let's think about, what does deposit do? Deposit is going to have a parameter, right? Because when you say deposit, you got to say how much you want to deposit, what amount. What do you think we want to do with that amount? Add it to your balance. You don't want to set your balance to be that, right? So if you have $7,000 and you say deposit 500 and your balance is now 500, that's bad, right? You want to add to it. So what do we do here?
Add plus.
Yeah, so I did this in 2 lines. I'll explain why I did this in a second, but actually I created a new variable called new balance, as opposed to like Nike or Adidas. It's called the new. Kids don't laugh at that either. So I have a new balance, and what's my new balance? It's going to be balance plus the amount, and then I assigned new balance to be my balance. Could you have just said balance equals balance plus amount? Yes. I just want to take the extra step of making a new little variable inside of my code here, just to show you how to make a little variable inside. We'll talk about that in a little bit. Make sense? That's deposit. Now, how about this? Get balance. Get ready here, this is mind-blowing. Guess what get balance does?
Get your balance.
Return balance. That's it. It's going to send it back to whoever asked for it. That's the code for it. That's it. How does it work? Don't know, don't care, but I know that's what it does. And I know the return statement gives me back the value that I asked for. Now, maybe I put it in a print line. Maybe I'm going to withdraw all my money, like we called the get balance method before, and withdrew it all. But all I know is that guess what get balance does? It gives me the balance. That's it, it's 1 line of code, 2 words. Return, and again, what is balance? It's my instance variable. Notice I didn't say new balance here. That was something I just used temporarily up here. What's my one and only instance variable? Balance. All right, so when I say mom savings.deposit, what happens here? It takes my money, my 500, it sets my parameter amount to be 500, the balance, instance variable, it retrieves that. It takes the amount and adds it to balance and stores the result in new balance, and then it takes new balance and replaces the balance instance variable, overriding the old value. Done. Made a deposit. That's how it works. Withdraw. A little bit different. Because what if I go to my bank and say, withdraw $1 million, and I ain't got $1 million? It says, no, you can't do that. So look what happens here. I want to withdraw this amount. They said, oh, well, let's check. If your balance is greater than or equal to the amount you're requesting, oh, here's an if statement. You've done if statements. Then what am I going to do? Here's the shortcut way, right? Balance equals balance minus amount. How else could I have written this? Balance
Equals new balance.
Well, I could have, but even shorter than this even. Remember the minus equals? I could have said balance minus equals amount. Yes, I could have done new balance here again. I could have done double new balance equals balance minus amount. Balance equals new balance. Could have done that again. But this is shorter, and I could have even said balance minus equals amount. Would have been a shorter way. But if I don't have it, it's going to print out insufficient funds. Right? So I have one right there's a power strip right up here on the wall. If you want to plug in right behind that, behind the yes, right? No, behind the blue thing hanging down here. Yeah, the big shoe rack right there. Yeah, look behind it.
Also known as a pocket strip?
There you go.
Oh my goodness.
That's my phone spa when I used to collect all the phones and stuff. So yeah.
I appreciate that.
No problems. So make sense? Oh, a little if else, a little logic in this one. So we have to check to make sure. And what about add interest? Oh, well, add interest, what does that do? that takes the interest rate, multiplies my balance by it, that's gonna be my interest, and then I could add my interest to my balance. Does that make sense? Now, here's an even more clever way. Instead of just saying balance equals balance plus interest, could I instead say deposit interest? Now wait a minute, deposit, that's a method, right? It's in this class. But I don't have to say object.method because I'm already working within someone's bank account. So I just say, hey, you know what? Calculate the interest and then say deposit interest. No object dot, just method. Because I'm already inside my own bank account code. With me there? That bothers some people, so there is a workaround. If you're always like, no, it needs to be object.method, object.method. You can't just call deposit, that breaks the pattern. Great, well you can do this. Literally, you can do this. This dot deposit, and that just means we're referring to this object. You don't have to do this. This is totally optional. You can just leave this off, and you can make a deposit. Good? All right, let's look at a completed bank account class, which I have here. I want to pull that. I couldn't even put it in the slides, but you can download it from eCampus, but I want to show it to you. Module 3. Here we go, bank account. And here is the completed bank account. So let's just go through this. I got my public class bank account. I've got my instance variable balance. I've got my two constructors, one which sets my balance to 0, one which sets my balance to initial balance. So far so good? Then I got my methods. What does deposit do? Deposits money into it using that new balance and rewrites it. What does withdraw do? Takes, if I have enough, I subtract it, otherwise I print insufficient funds. What does add interest do? It takes my interest and I call it deposit at interest. I could say this dot deposit, or I could have just said balance equals balance plus interest. But this way, if I have something else tied to a deposit, like maybe there's a transaction fee that I don't know about, I can put that in one place or something. And then here, get balance returns my balance. That's my total bank account class. That's the blueprint with all the instructions for every bank account object that I create. So here, what does this print? Take a second here. So I got 3 bank accounts. I got Mom's savings has 8,000, college fund is 1,000, dad's checking is a new bank account with shocking, nothing. Deposit 1,000, add interest 10%, withdraw 1, dad's checking, trying to withdraw $100,000. But notice, none of this prints anything until withdraw prints something. Then I have an amount, I do a transfer, and then I have some prints here. Take a second, see if you can figure out what this prints. Just in the interest of time, I'm going to go ahead and walk you through it here. So we got this. Notice I got my 3 accounts, and if you kind of drew, okay, mom's savings 8,000, college fund 1,000, dad's checking nothing. I deposited 1,000 into my college funds. Now 1,000, my college fund is 2,000 now, right? Excuse me. Add interest 10%, 200, 2,200. Okay. Withdraw $100,000. What's that going to do? Oh, it's going to print insufficient funds. That's the first thing that gets printed is insufficient funds. And then I do what? I transfer 500 from mom's savings to dad's checking. So mom's savings is going to have 7,500, and dad's checking is now going to get 500, right? So now what's it going to print? Mom's savings get balance, 7,500. Dad's checking dot get balance, 500. College fund dot get balance, 2,200. You've just put together a class, made some objects, and used it. So it prints out insufficient funds because the Joker trying to withdraw $100,000. But then we also have after that we have the come on, tell me I'm still recording. I believe I am. Yes, great. Then we have we're gonna deposit and add interest as we did. We're gonna transfer a certain amount into dad's checking, and then we print out the 3 balances, which we did right here. Questions on that? Couple of the last things about classes I want to mention here. First of all, accessing instance variables. Remember we said we could do this, right? The deposit method has access. The deposit can change my balance, right? Because it's a method. If I was in my main method, like we just were over there, could I just say new bank account 700 and print my account dot balance? I can't. I have to call the get balance method. I don't have access to my balance directly because that's a private instance variable. That's the idea of abstraction and encapsulation, hiding the details, right? So that's something that we talk about with instance variable. That's why they're private. You cannot access them outside of the methods themselves. The instance variables are what we call global scope. Anywhere within the class, you can modify your balance or access it. Local variables have local scope. These are variables that are only within the method. Remember that new balance that I did, look a little overkill? That was an example of a local variable. It only existed in deposit. When deposit was done, new balance went away, right? Global, and then another parameter also is local scope. I could only use amount in the deposit method. I couldn't call the get amount method. There's no get amount method. Amount was just for that one instance of calling a withdraw or calling a deposit. Here's the amount I want to withdraw or deposit. So those are what we call different scopes. So let's do some questions here. Now this is pseudocode, so it's not exactly Java, but it's Java-like, and you'll see some of this in the test. This one says, which variable would be considered global? So now, remember where my instance variables were. It was not inside of a method. Where was my instance variable? It was outside of the method, right? It could have also been in between the methods, but it wasn't within the method's curly braces. Does that make sense? So here, this function 1, I've got an integer x, that's within this function. This main program, I've got an integer z, that is within this main program. But what variable is between the functions? So it's global, that's going to be y. What's my global variable? That's going to be y. Hey, let's try another one here. This is actually Java. Well, it's sort of Java. It's pretty close. It says, which line of code constructs an instance of a class? So I've got this class test rectangle, which looks like it's using the rectangle class. Where am I creating an instance of the rectangle class? James says 9. Line 9. Rectangle, rect, equals new rectangle. I'm making a rectangle object here on line 9. And I'm giving it the corners and the width and the height. Does everybody see that? That's where I'm constructing a rectangle object. The answer is C, 9. Good. These are the types of questions you would ask because, again, you are very well versed now in classes. How about this one? According to the code segment below, which is the rectangle class, this is the blueprint for the rectangle class. Which method can only be accessed from within the class? So we said, which method can I not use outside, but I can only use it within the class itself? And I mentioned there's something about a particular method that would say I can only use it within, I can't access it from outside the class. I've got what methods? I've got find area, find perimeter, set height, and set width, but one of them is different. The private one, which one? Find area. Does that make sense? So find area is private. That's the one that can only be used within the class itself because it's private. Cool. One more, I think. Yep. In object-oriented programming language, encapsulation is most likely to be implemented through the use of what? How would we have this idea of encapsulation? The idea of a single object. What's our single class going to have? Private data. And then methods as well, not private methods, but it's private data along with methods. That's what encapsulation is all about. Oh, I lied, I got one more here. This is another FTE question about classes. A lot of classes here. Here I've got this class testing functions. It says, what will be the output from these lines of code? Oh, let's look. So I've got x equals 5. I have a testing functions called test. That's a terrible name for a class, by the way. Testing functions. Should be like an object of some sort. Equals new testing functions. So what do I got? I've got, I don't have a constructor, but I've got these methods, fun and fun2. So what happens here? X is 5. So do we agree x is going to be sent to this variable b? Is everybody with me here? Because x was 5. So I'm going to call the method fun2 with a 5. B is now 5. B minus minus. What's b now going to be? 4. And what am I going to do with this b? Oh, I'm going to call the fun1 method. They decided to say this dot, but fun1 is up here, right? What's b? B is 4. Everybody with me here?
Yes.
4 is going to be a. A is 4. And now, what is a plus plus going to do to the a? It's now 5. And what am I going to do then? After the a plus plus? I print it out. What's going to get printed? That's it. Cool. All right. To wrap up here in the last couple of minutes, let me show you what we got for this week. So, questions on this? Everybody good? Those are 4 or 5 good FTCE questions. You notice you didn't have to write any code, but you had to know what parts of a class were important to point out. That's the types of things they're going to ask you on this test. Good here? All right. So a couple of things. CS Awesome. These are some sections in CS Awesome. I put it up there beginning, but these are some good ones to talk about constructors, accessors, and mutators. They also call them setters and getters. Setters would be like a deposit or withdraw, sets a variable, and getters is like get balance, gets me the method. I hate that term. I feel like I gotta be teaching in Mobile, Alabama. I got my getters and my setters. I'm sorry if anybody's from Alabama. But I call them accessors and mutators. And it talks about scope and everything else. This right here, if you want some extra practice, multiple choice, this 514 has some really good problems, and they explain each one. Here is your assignment for this. There's a class called employee. What are some attributes of an employee? And you'll see it started for you. You just got to fill in the missing parts. An employee has 3 instance variables: a first name, a last name, and an annual salary. And it has 3 parameters, and you're going to initialize the instance variables. You'll see that in the code, what it looks like. Then there are these 4 methods. Get initials. If the name is John and Smith, you would return JS. Can you get the first letter of the first name? You did this with Pig Latin, right? First letter of the last name is going to return those 2 letters together. Get weekly salary. Can you take the annual salary and divide it by 52? That's what the annual salary is. Can you give them a raise? Hey, isn't giving someone a raise very similar to adding interest? You got the code for adding interest. And then finally, get annual salary. Oh, that just simply returns the annual salary. Those are the 4 methods that you're going to write. You'll see them started for you. We're not writing these from scratch. Download from eCampus. There is that employee class. Download it, and you'll see it started for you. You could cut and paste it, but I would just download it and open it right up in JGrasp. If you need some help with that, let me know. And then there's an employee tester. An employee tester creates an object called Agent 007 with the name James and Bond and 104,000. And then what it prints out is you'll have to prints out JB weekly, so it gets the initials and prints out the weekly salary, gives them a raise, and then prints out JB new salary and has their new annual salary. Then what you need to do after that is you make your own employee object with your first name, your last name, whatever salary you dang well please, and then give yourself a raise and do the same thing where it prints out your initials. And the idea is to show I have one object using the employee class, and you're going to create a brand new object using the employee class, and they have different salaries, different names, different initials, everything else. Make sense?
Yeah.
All right, so this is what we got. I would recommend checking out Unit 5, looking at study.com. Download bank account tester, print triangle, all that stuff is in CS or is in eCampus. You can download those and run that bank account code that we went through together. That's up there. You can use that code. But you're going to download employee and employee tester, finish that class, use that class to make an employee object called Agent 007. That started for you. Make your own employee object, and then take the Module 3 quiz and try to get 80% or better. If you got any questions along the way, please let me know. I'm going to stop there, but let me see if I can stop. I'm still in. Good. All right, I'm stopping here.